Okay, hello students, and welcome to today's Friday Happy Math Hour. Today we're going to be covering solving the exponential and logarithmic functions. Okay, but before we start, we're going to do a little review of what we did last week. Okay, this is the topics that we're going to cover this week. We're going to be writing logarithmic equations into exponential equations, writing exponential equations into logarithmic equations, solving exponential equations by using the same base rule, solving exponential equations with different bases, and solving logarithmic equations by using logarithm properties. Okay. So this is a review from last week because this important topic that's a continuation of what's going to continue today. Example 1, write each logarithmic equation into an exponential equation. They give us log base 981 equals 2. Right, so we have to go from logarithmic to exponential. Right, and here's a formula for or the form for logarithmic, and a to the y power equals x is an exponential. So we have to know what the a is, what the x is, and what the y is from the log equation, and then we have to write it into an exponential equation. So my a, if you notice, is equal to 9. My x is equal to 81. And my y is equal to 2. Now it's going to be a, right? My a is 9. It'll be 9 squared equals 81. You see there's my a, there's my y, and there's my x. Now we're going to go the other way. Write each exponential equation into a logarithmic equation. So again, we have to know what the a, the y, and the x is. So my a is going to be 5. My y is 3. And my x is 125. So it's going to give us 3 equals to log a base 5 by 125. You see there's my y is 3. My a is 5. And my x is 125. This can be written in either format. If you want, we can put log a base 5 by 125 equals 3. These are the same thing. They're equivalent. Now, why is this crucial? Because in order to graph without a calculator, you must convert logarithmic equations into an exponential equation. So I'm going to graph one of each, one exponential and one logarithmic, and then we'll start what was covered this week. Okay, now right, so these are all exponential functions. This is something that I covered last week, right? Why? Because the exponent is a variable. That's why these are called exponential functions. Now, the a is a base. The exponent is a variable, which is a letter, okay? But it's not called a letter, it's called a variable. And frequently it's going to be x. Okay? And it says that f of x equals to a to the x power, where there has to be more than 0. Okay, now. Okay, this was example 3 from last week. So here, guys, we're going to graph an exponential, an exponential equation first. The points that we need to plug in for x is -2 all the way to 3. At times, -2 to 2. It all depends on the base. But in this case, right, we're going to get a little table. So when x is -2, I'm going to plug in -2 where the x is, over here on the right. Right? So the answer will be equals 1 over 2 squared, which is equal to 1/4. And the negative exponent rule, we covered that also last week. So when x is -2, my y is 1/4. When x is -1, we're going to evaluate the function at -1, which means it's going to be 1 over 2 to the first power, which will be 1/2. So when x is 1, my y is 1/2. When x is 0, anything to a 0 power is always equal to 1. So when x is 0, my y is 1. Now when x is 1, right, my y is going to be 2. So when x is 1, my y is 2. And when x is 2, my y is 4, because 2 squared equals to 4. And finally, when my x is 3, my y will give us 8, because 2 cubed is 8. 2 times 2 times 2 is 8. So when x is 3, my y is 8. And here's my graph. This is like the normal graph of an exponential function. It always starts low and it goes high as the x gets bigger, it goes higher and higher and higher. Okay. Now let's graph the logarithmic function. So before we graph it, right, we have to convert it to an exponential function. Right. So remember it'll be a to the y equals 2x. So this will give us 2 to the y power equals x. Now, but instead of plugging in the values for x, we're going to plug them in for y. Because if we plug them in for x, right, we have to use certain log properties that it'll be more complicated. So instead of plugging in for x, we're going to plug them in for y because it's much, much simpler. So again, when x is -2, right? So these are the values. When you plug all these in for the values for y as the exponent, it's going to be 1/4, -2, and so forth. And here are my two functions. The one in red, the one in blue is my exponential function, and the one in red is my logarithmic function. And all this, I explained it last week. This is just like a quick review, okay? And again, let's start solving exponential equations. But before we start, there are certain things that you gotta know, okay? For example, we need to know previous topics such as perfect squares. These are perfect squares because 2 squared is equal to 4, 3 squared is equal to 9, and so forth. Try to know all the way to 100, like 10 squared equals to 100. And these are perfect cubes. At least know all the way to 6, like 2 cubed is 8, 3 cubed is 27, and so forth. And to the fourth roots, at least know all the way to 5. 2 to the fourth power is equal to 16, 3 to the fourth power is 81, and so forth. Also, you must know exponential expressions, right? A is called the base, M is the exponent. We also have to know the exponent rule, the exponent power rule. If you have a base raised to a power raised to another power, you multiply the powers. This is crucial for today's lesson. And also, you must be able to solve one variable equations and even quadratic equations also, but mostly it's going to be one variable equations. Like, for example, 2x plus 8 equals 14, something like that. Okay, so let's start with the first example here. It says, let A be positive real numbers with A cannot equal to 1. It says, if A to the U equals A to the V, then the exponents must equal to each other. In other words, if you have the same base, right, the A is a base. If you have the same base, then the exponents must equal to each other. Okay, example. This is a quick, easy example, right? We have the same bases, right? Both are base 3, so x must equal to 5. Right, so same base, we apply the rule. X equals 5. That's why you apply this rule here. But it's not going to be this simple, right? At times it gets a little bit more challenging. For example, this one here, okay? If you notice, example 6, they're not the same bases. They're not, right? So my lowest base here is going to be, right, we know that 8 is equal to 2 cubed because we're trying to make it with a base 2. And 8 is equal to 2 cubed, right? So then what I'm going to do, I'm going to substitute 2 cubed where the 8 is. Right? We belong the exponent equals to 2 to the first power. You see, they're not the same base, so we have to apply here the exponent power rule. When you have a base raised to a power, raised to another power, you multiply the powers. Okay? You see now, guys, now we got the same base. So now we let the exponents equal to each other. We divide both sides by 3, and the answer will be 5/3. And you can always check your work. Okay? For example, I'm going to plug in 5/3 right where the x is. Now, if you want, you can put this in a calculator, how it is. 8 to the power of 5/3 equals to 2 to the 5th power. You should get something like 32 equals to 32, so I know that's correct. But we can apply the rule that we learned last week, the fractional exponent rule. This is without a calculator, okay? So 8 to the 5/3, we have to convert it to a radical. So the A is a radicand. The denominator is your index, and the numerator is the exponent. So what's the cube root of 8? Right? It's going to give us 2. 2 to the 5th power. This will give us 2, and then we put on the 5. So 2 to the 5th power. So if you notice, they're equivalent, right? That's why we know this is my correct answer. Okay, now look at this one here. We have 9 and we got 27. If we do 9, right, we know that it's not the same base. If we do 9 squared equals to 81, right? So 9 squared is too much, is too more than, I mean, is way too much than 27. That means we have to see if they have a common base in common. Okay? So, right, so we know that 9 is equal to 3 squared. And 27 is 3 cubed. So then I'm going to replace 3 squared with a 9 is. Bring down the exponent, the x. And I'm going to replace 3 cubed for the 27. Right? Now, on the left side, I'm going to apply the exponential or the exponent power rule. Right? Which means when you have a base to a power raised to another power, again, we multiply the powers. You see now, guys, we got the same base. Now, the rule can be applied. So 2x equals to 3. We divide both sides by 2. So x equals to 3 over 2. And again, we can check our work, right? We know that the solution was 3 over 2. We plug it in for the exponent, and we use the calculator or the converting from exponent to radical, right? So we know that this is correct. Example number 8. If you notice, each one gets a little bit more challenging, right? But it's all the same concept. Again, we have the base is 4 and the base is 32. So they're not the same base, right? So that means that we have to change it for them to have the same base. But we do, when we first start, this is a strategy. You always get the smallest base and see if you find the power, if the base raised to a power give you 32. Let's see. 4 squared is equal to 16. That's not equal to 32. So let's try 4 cubed. You see, that's too much, which means they both have to have the same base, right? So we're going to see if they have a base in common. Okay, we should know that 4 is equal to 2 squared. And 32 is equal to 2 to the 5th power. You see, now they share the same base. So for the 4 is, I'm going to replace it with 2 squared. Bring down the exponent, the x minus 1. And for the 32 is, I'm going to replace it with 2 to the 5th power. Now on the left side, we're going to apply again the exponent power rule, right? Which means, again, a power to a power. So we're going to multiply 2 times x minus 1 equals to 2 to the 5th power. Now the bases are the same, which means we can apply the rule. Right, so we let the exponents equal to each other. So here, my next step is we're going to distribute. So it'll be 2x minus 2 equals 5. Now this is where just basic algebra. So we're going to add 2 to both sides. Right, and then we divide both sides by 2. So the answer will be 7 over 2. Now, again, let me check my work. So I'm going to plug in, the solution was 7 over 2, so let's plug it in for the x's. 7 over 2 minus 1, right, is going to give us 5 over 2. If we have 4 raised to the power of 5 over 2, is going to give us 32. So I know that's my correct answer. Okay. Solving logarithmic equations. Okay, now to solve logarithmic and exponential equations, you need to know previous properties, such as these are the rules for this is called condensed or a single log, and this is called expanded. So we have to know those rules, and I believe those rules we covered them last week. No, we didn't. We're going to cover them right now. So anyway, we know that if you have the log of base a of x times y is going to equal to log of base a x plus log of base a y. If you multiply them, right, with a single log, you can expand it by the sum. If you have the quotient, right, like log of base a of x over y, we're going to expand it, but we're going to subtract them. if you have log a base a x to the power of r, if you notice the r or the power goes to the front. Okay, and the same thing with the ln, right? Same properties apply, for the ln. Now let's do recall example number 7. That in this case we have to find the same base, right? But there's another way to get the answer. We're going to get the same answer, but there's another way. And I will tell my students that they can use it either way. If they don't like to be searching for the same base because that's a little bit more thinking and more work, you can always apply this rule. And this rule, it always works. Okay, here's how it goes. Remember the answer was 3/2? But now we can solve by using the power property of the natural logarithm. Okay, so we're going to be, this one is like rule number 3 here, like the power rule. Okay, here's how it works. We want to bring down the x, right? So we're going to apply this rule here. The ln of x to the power of r, right? The exponent goes to the front. So we're going to take the ln of both sides, right? We do that to both sides. So on the left side, right, by applying this rule here, let's call it rule number 3 for the power property. The power or the exponent goes to the front. So the exponent goes to the front. Now we can divide both sides by the ln of 9. We can put that into the calculator, and it's going to give us 3/2, or 1.5, which is 3/2. You see, guys, we get the same answer. Okay, and very important, guys, the ln of a number is an actual value. You cannot separate them. For example, a lot of students will say, "Oh, okay, here I'm gonna eliminate or cancel the ln's," and we got 27. No, you cannot do that because the whole thing, the ln of a number, is actually a value. You cannot separate the ln and the value. It's all together. Okay, so please don't make that mistake. Now here's another rule. Okay, if you let u and r are real numbers, here's a rule that we're talking about right now, that the exponent goes to the front. Okay, example. They always tell you guys, this is the steps that the book states. It states first, try to find the common base, right? And then if not, use this property here, the ln property. Well, you know what, guys? You can go straight to this property here. You don't have to try to find the common base if you don't want to, unless your instructor specifically says to solve by using the same base. Okay, it's up to the instructor. Okay, but with me, guys, I'm sure that I'm gonna take my courses. I'll let them, do it any way that they want. As long as they show me the work. So in this case, I'm gonna take the ln of both sides. But to apply with the textbook, right? These are not the same base, and we cannot get the same base, right? That's why we use the ln. So I take the ln of both sides. The exponent goes to the front. We divide both sides by the ln of 5. Right? So we have ln of a divided by ln of 5. And it's going to give us like an irrational number. Right? So they always want you, this squiggly lines means that it's approximated because this number will never end. It'll be something points, something that will never end. So that's why it's gonna state to run that off to 4 or 5 places. Okay. Check the answer, right? So 1.2920, right, is being rounded off to 4 decimal places. Now we can check the work by plugging in 1.2920 for the x's, right? It's going to give us something real close. Why is it real close to 8? Because we round off here. That's why there's no exact answer. That's why the answer will be 1.2920. You see, but this is very, very, very close to 8. That's why this is my correct answer. And I believe this is right here. We're using My Math Lab. So I think My Math Lab is going to require for you to round off to 4 or 5 places. Okay, so follow the instructions of My Math Lab. So my result is 1.2920. Now, this example here, guys, is the hardest it gets. Okay, it cannot get any harder than this. So here, guys, there's no same base, right? Because 3 and 5, they don't share a common base. So right away, we're going to take the ln of both sides by bringing down the exponents. Okay. Now the exponents, right, come to the front by using the property. So the x plus 4 goes to the front, and the x minus 3 goes to the front on the right side. Now I'm going to distribute. Okay, ln of 3 times x give us x ln of 3. Why do I put the x first and the 4 first? Because if you put the x at the end, it seems that it's ln of 3x. That's why, to eliminate confusion. Okay, or you can put parentheses if you want to, but this is the best way to do it, is to put the x first and also the 4 first. So the ln of 3 times x will give you x ln of 3. The ln of 3 times 4 will give us 4 ln of 3. In the same process on the right side, the ln of 5 times x will give you x ln of 5. And the ln of 5 times negative 3 will give us negative 3 ln of 5. So in this case, we're trying to solve for x, correct? So every term with an x, I'm going to send it to the left. And every term without an x, I'm going to send it to the right. Okay. So here I'm going to subtract x ln of 5 from both sides. And at the same time, I'm going to subtract 4 ln of 3 from both sides. This way, right? This will give us 0 on the left and 0 on the right, right? For 4 ln of 3 minus 4 ln of 3 will give us 0, and same thing here, but we have to add x ln of 3 minus x ln of 5. We cannot combine them. Why? Because they're not like terms. Same thing on the right. We cannot combine these because they're not like terms. Now on the left side, I'm going to factor out an x. Right? So if I take out an x, we'll be left with ln of 3 minus ln of 5 equals to negative ln of 5 minus 4 ln of 3. Now to solve for x, we divide both sides by ln of 3 minus ln of 5. So this is my solution, guys. This is the exact answer. And I believe now, because if you round off at the beginning, then at the end you're going to be it's going to be real close to the answer, but I believe it's going to be wrong on my math lab. That's why you always get it to the exact. This is my exact, and then here you're able to round off. So just put that in the calculator, right? So I'll be all this with parentheses divided by all this. The denominator, everything with parentheses, and then enter is going to give you a value, which would be something like 18.0546. And you can check your answer. So I'm going to plug in 18.0546 for the XR, for the exponents. So both are going to give you something real big. What's this, like 33? This is a million. So it'll be 33,320,677,110. So this is my solution. Okay. So I know the 18.0546 is my answer. Now solving logarithmic equations. Let's do so here, guys, we're going to use more properties. Okay, so this property says let u, v, and a be positive real numbers with a cannot equal to 1. Then if you have log a base a u equals to log a base a v, then u must equal to v. Example. Right? So here, guys, right, the base for these two is 10, because if there's no base, it means it's base 10. Right? Single log with the same base, both sides, so we can apply the rule because both are base 10, right? So now we let the x is like my u, and the 3x minus 6 is like my v. So we let them equal to each other. I subtract 3x from both sides. So it's going to give us negative 2x equals to negative 6. Divide both sides by negative 2. The answer will be 3. Now, again, we can always check our work, right? So x is 3, so let's plug it in, right? There'll be log of 3 equals to log of 3 times 3 minus 6. It's going to give us log of 3 equals to log of 3. Now, one thing that you guys have to know is that the natural logs or the logarithms cannot be 0 nor negative. They have to be more than 0. Okay? Again, same rule. Okay, now look at this one here. You notice number 12 is a little bit different than the previous example. Here in this case, I cannot use this rule because the right side has to be as a single log. So first, on the right side, I have to simplify it. Right, so I have to apply the product rule. So I have to condense this. It has to be only as a single log. If it's addition, right, then this becomes multiplication. So now these two, this one is equivalent on the right side. Again, this is expanded, and this is condensed. Okay, now, let's see here. So now, right, so now we apply the rule, and we let u, right, this is like my u, and this whole thing here is like my v. Now on the right side, I'm going to distribute, or use the FOIL. It's going to give us x squared plus 3x minus 2x minus 6, because x times x will give us x squared, x times 3 will give us 3x, negative 2 times x will give us negative 2x, and negative 2 times 3 will give us negative 6. Combine like terms. So it'll be x squared plus x minus 6. Now, right, since we have a square, we have to let it equal to 0, because we're going to factor. Okay, we're going to factor, so we're going to subtract x and negative 3 and 3 from both sides. So the left side is going to give us 0 equals to x squared minus 9. Now, x squared minus 9 is a difference of two perfect squares. So it's going to give us x minus 3 and x plus 3. So my answers are going to be, right, so we let them both equal to 0. It's going to be x minus 3 equals 0 or x plus 3 equals 0. So on the left side, we have x equals to 3. On the right side, we have x equals to negative 3. So these two are my solutions, right? So now let's check them. Let's first check the negative 3. Right, so let's plug in negative 3 for all the x's. You notice on the right side, it's going to give us log of 0, which is not defined, right? Because if you put log of 0 in your calculator, it's going to say error or not defined. That means negative 3 is not a solution. Okay. Now let's try the 3. So we plug in 3 for every x. We get log of 6 equals to log of 1 plus log of 6. If you put this in a calculator, right, if you simplify this, guys, log of 1 equals to 0. So it means that log of 6 equals to log of 6. So I know this is my correct answer. So that's my solution. Now let's try another one, same with the same properties. But this time, right, on the right side, it's going to be, if it's minus, it's going to be division, right? So we have to apply the logarithmic properties, right? If it's subtraction, it's going to be the quotient, and we're going to write it as a single log. Now they have the same base, right? So now we let the x equal to x plus 3 over x minus 1. Here, guys, I'm gonna cross multiply, right? So on the bottom of x is like a 1, so it'll be x times x minus 1 equals to 1 times x plus 3. Right? Or you want to, you can also multiply both sides by x minus 1. Because if I multiply both sides by x minus 1, on the right side, the x minus 1 and the x minus 1 on the bottom are going to cancel. On the left side, we have x times x minus 1. Now on the left side, I'm going to distribute. So it'll be x squared minus x equals to x plus 3. Now since we have a square, right, I'm going to subtract x minus 3 to both sides. Negative x minus 3, right, because this one on the right side is going to give us 0. We have x squared minus 2x minus 3 equals 0. Now we can factor. And I believe I did this workshop on factoring on week 3. The factoring process for x squared minus 2x minus 3 is x minus 3 and x plus 1. Set them both equal to 0. We have x minus 3 equals 0, so we're going to have x minus 3, x equals to 3 on the right, on the left side, and x equals to negative 1 on the right side. Now we can always check our work. Let's go to the next slide and check our work. So first, let's check the negative 1, right? So let's plug in negative 1 right away. We know that right away this is not defined. Log of negative 1 is not defined. So that's not a solution. Now let's plug in the 3. Right, you see, notice the 3 is in next. And then use color coded, guys, just because when you use color, it makes it come to life. I mean, that's why I like to use with my PowerPoints, I like to use animation and also use color. So then, right, so here on the right is going to give us log of 6 minus log of 2. Now here, guys, you can actually put into the calculator, or else you can use the rules, right? You use the calculator, it's going to give you, so I know this is correct because both sides give you the same value. But if you want, you can also solve it by using the properties. So if you have log of 6 on the right side minus log of 2, right? If it's a minus, you can condense it by using the quotient rule or the quotient property. You see, guys, log of 3 equals to log of 3. So this is, so 3 is a solution. Now, here are more properties now. Okay? If you have if A and U are positive real numbers with A equals to A cannot equal -1, then A raised to the power of log of base A of U equals to U. If you notice, guys, the A is my base here, right? A is my base. Also, the A is the same base for the log. So if both bases match, then all you do is bring down the U. That's why A log of base A U equals to U. Example in this case, right? So here, this is what we're going to do. So I'm going to make it, right? So if it's a 3, I'm going to let this be my exponent, and then my base will be 3. By putting a base 3, right, on both sides. You see, now these becomes my exponent. So here on the left side, by applying the rule, this will equals to 1, right? So it'll be 6x minus 2. We bring it down. And 3 squared will give us 9. Now we add 2 to both sides. So 6x equals to 11. We divide both sides by 6. And we get x equals to 11 over 6. And again, we can apply the rule, right? Again, we can check it. I'm sorry about that. We can check our work. So we're going to plug it in where the x is. Right? X is 11 over 6. So this gives us log of base 3, 11 minus 2, because 6 times 11 over 6 will give us 11. Now 11 minus 2 is going to give us 9. Now if we put this in the calculator, guys, it's going to give us 2 equals to 2. So I know that's my solution. And I believe, guys, I finished a little bit early. But if you have any questions, please put in the chat so I can help you, or the tools can help you. I think I went, like I said, I think I went a little bit too fast. So maybe next time I should talk a little bit slower. And but let me take you guys back to the host, Ms. Patricia, so she can promote what's going to happen later on today or next week.
Thank you very much, Mr. Isasi. This is Pablo, and we thank you for your presentation. If you have any questions, Areli, now is your chance. I mean, you're the only one in this room, so you have Mr. Isasi all to yourself. If you have any doubts, any questions, anything that you need to be explained a little bit further, Mr. Isasi is all yours. If not, you can join us later on today for the student success topics, which is at 1 p.m. We have a visit from the Veterans Resource Center. And then next week, we will have our Happy Math Hour final of the before the spring break. And so Math 1314 will be finding zeros of polynomial functions. Math 1304 is simple compound interest and annuities. And then the student success topic would be the Pasos, Cesar Chavez, and Oral History Project. So Areli, if you have any questions for Mr. Isasi, either type them in the chat or go ahead and turn on your mic, and Mr. Isasi is all yours. Thank you.
Thank you, Pablo.